Hello everyone, here's chapter 1, the first section, Introduction to the Practice of Statistics. Okay, on the first part we have a definition for statistics is the science of collecting, organizing, summarizing, and analyzing information. So we're gonna have all these steps, and using these we can draw conclusion. The next one here is data or information. Data are facts or proposition used to draw conclusions. So we're going to use all these data or information that we collected. Using this information, we can draw a conclusion, or in other words, making decision. Okay, we may have different type of data, different information. For example, you may ask, is everyone in our class the same height? What the answers are for that part. Or under one, you may ask, does everyone have the same hair color? So having under data on this part, so we have different type of information. Here we have another example, again, different questions. We have, do you sleep the same number of hours every night? And what the answer is for that part, do you consume the same number of calories every day? So we're gonna collect all these information, and then draw a conclusion for that or making decision. Okay, what we have here is, here on this part I have, this part is population, so whatever you have inside this part, so all these members here inside this part are population. So population is all the possible data that we have here in this part. And what we chose to have these 5 circles is like having, okay, one of these. So each one of these that I have in this color is blue. So if each one of these are samples, our sample in this case is these 5 circles. So sample is subset of population. So it's part of our population. So the entire group of individuals to be studied is called population. And an individual, so each one of these, and individual is a person or object that is number of population being studied. So a sample is subset. Sample is subset of population. Okay, let's have an example for this part. Sample the population could be our classroom, and the sample could be all students in their front row. Okay, the next part is descriptive statistics. This consists of organizing and summarizing data. So here again, we're gonna organize and summarize our data or information. And that describe data through numerical summaries. Next part, statistic, is numerical summary based on sample. So this part's important. You may have these statistic and parameter on your test or on your homework. When you saw statistic, that means that you're working on a sample. When you have parameter, you're working on population. So this is starting with S, and here sample also is starting with S. So when you have stat, you have sample, and that is numerical summary based on sample. The next part, so in this part we had descriptive. Now we have inferential. Inferential statistic uses methods that take results from sample, extend them to the population. So actually we're starting with sample, but extending it to have population. That's why here for parameter we use population instead of sample. So now parameter is, again, we have numerical summary, but instead of sample, now we have population. So these two are important. Example, identify whether the data represents a statistic or a parameter. Number 1, suppose a percentage of all students on your campus who have a job is 84.9%. What we have here is that I have this part, all students. So what we're using here is all students on your campus. Is exactly same as this part. All students in our classroom. That one was population. So this means here we have population. This is population, and since we have population, this means here we use parameter. So population summary is given. Therefore, this one is parameter. Number 2, suppose a sample of 250 students is obtained. And from this sample, we find that 86.4% have a job. I don't care what the percentage is here or here on this part. We only need to focus what we have here. Is that population or sample? Now in this part, we have sample of 250 students. Since we have sample, that means that I used statistic. So sample summary is given. Therefore, this one is stat. Okay, next page. Now in this one we have qualitative versus quantitative. The definition for variable. Variables are the characteristics of the individuals within population. So this is within population. Next one, qualitative or categorical variables is based on some attribute or characteristics. Example, let's have example for this part. Example for qualitative. We can have gender, nationality, race, and names. So this part is not numerical measures on individuals. I'm not able to count these. The next one is quantitative variables provide numerical measures of individuals. So this part, this means I can count these. Example. Okay. So here we can count these values. But here for qualitative, we were not able to count, so we cannot count. Example, we can have number of siblings. So this is number. I'm able to count them. Under one, value of a house. Since I have this one value, we have a number for this. What is the price of that house? We have number. It's countable. Next one, example, classify each of the following variables considered in a study as qualitative or quantitative. The first one is nationality. I have exactly same example here on top. So that is qualitative because we're not able to count this one. This one is qualitative. Here is number of children. We are able to count these. So this is quantitative. Here is part C, household income. We can count that. Again, quantitative. This is level of education. We're not able to count that. It's not number. So it's qualitative. Part E, daily intake of whole grains, measured in grams per day. We're able to count this. So this is quantitative. Next part, discrete versus continuous. Discrete variable is quantitative variable, so meaning that we can count these. That has either a finite number of possible values or a countable number of possible values. So, as I said, this one is countable. because this is quantitative variable. Okay, the term countable means the values result from counting, such as 0, 1, 2, 3, and so on. Example. Example, I can have points in a game. Another one, number of cars. Okay, so here we have points, we're able to count them, and here is number of cars, again is countable. The next one is continuous variable is quantitative variable that has infinite. So the difference between these two is that here we have finite number, but here we have infinite number of possible values we can take and can be measured to any desired level of accuracy. Example. So we're able to count, but the number is infinite. For example, I can have height, weight, time, temperature, one more, speed. So here discrete variables are a finite number. But here continuous we have infinite. Okay, next page. Other example, classify each of the following quantitative variables in considering a study as discrete or continuous. We want to see if these are finite or infinite. So here it is. This is finite, and this one infinite. Goals scored in a season by a soccer player. So their score may be like let's say their score was 2 or 3 or 4 or 5. So they have specific number in there. That's why that is finite number, and that's why here is discrete. You cannot have infinite numbers for that one. Volume of water lost each day through a leaky. So here we have volume of water lost each day. So I don't know how many days we have here. That's why we may have infinite numbers. So infinite data for this part B. So that's why this is continuous. Part C, length of a country song. So we don't know what song is. You may have many songs here, and as you can see here on this part, I use height, weight. You may have length. There's another example for this part. So all of these are continuous. So this one also is continuous. Part the number of okay, what do we have here? Okay, how many tourists we have here in this Yosemite National Park? We can count them. So this means number we're gonna have is finite. So this is discrete. Okay, next part, levels of measurement. We have 4 parts: nominal, ordinal, interval, and ratio level of measurement. The first one is nominal. So this one deals with names, categories, and labels. And here data are qualitative. So I'm writing that part here is not. So that one is not here. So data are qualitative. And also they cannot be ordered. Okay, example. Here again I have gender. Remember, since I said, okay, this is qualitative, and here on top, for qualitative, I use gender, nationality, race, names. Here again, I'm using gender, race. Let's use another one, not exactly what I use on top. So gender, race, color of eyes. Another one, blood type. Okay, next one is ordinal level of measurement. It has the properties of nominal level of measurement and okay, here we can arrange them. So on top I said cannot be ordered, but here we can order. So on this part we have ordered. We can have ordered names. So data can be, okay, I want to write same way that I wrote on top. Data can be ordered. But here on top, we were not able to order them. Example. Letter grades. We can have A, B, C, okay, and D, F. All of you should get A. Okay, another example. Rank of winners. So rank, okay, I'm writing this way. Rank order of winners. Who is in first, second, and third place? Another one. We have freshmen, juniors. These are in order. One more. First, second, third. These are again ordered. Next point, interval level of measurement. Here again, and this part deals with data that can be ordered. So it has properties of ordinal level, so we can order them. And on the probability value of 0 in the interval level of measurement doesn't mean the absence of quantity. So for example, if the answer was equal to 0, that doesn't mean that you don't have that part. That means that, let's say, one example, what if the temperature was equal to 0 degrees? That doesn't mean that you don't have temperature. Actually, you have temperature, but the temperature is equal to 0. But depending on what that is, as Celsius or Fahrenheit, you can convert. But the point is that if the answer was equal to 0, you actually have a number in there. But for ratio level of measurement, here value of 0 in the ratio level of measurement means the absence. So we shouldn't have 0 in there. Okay, so here data. Can be ordered. Data does not have a starting point. What that means, okay, it can have 0. So it doesn't have starting point. What that means, I'm not saying that, okay, you should start with 1. What that means, you don't have 0. If you have 0, that means that you don't have that part, and it's absence of quantity. But actually, just 0 means we do have that quantity. So it doesn't have starting point. We're not starting with 1 or whatever number is. Okay, in other words, numbers where 0 is not the beginning point. example. Example again, temperature. Credit score. Next one, ratio level of measurement. Here again, we have same thing, data can be ordered. And the sport data have starting point, so is and the first part was exactly same as the interval part, but here instead of having doesn't have starting point, we do have starting point. In other words, numbers where 0 is the beginning point. Okay, example for that part. You can have energy used, value of a car, weight, height, so we can have many. All these examples for that part. Now example 5, determine the level of measurement of each variable. The first one is a nation of origin. This cannot be ordered. This is the first part is nominal. We have name, so this is nominal. Movie rating of 1 star, so it's 1 star through 5 stars. We can write them in order, so this is ordinal. C, volume of water used per day. So volume of water used per day, this is ratio. Part D, year of birth. So let me add that one here. So this is another example for this part. That is interval. Part C, highest degree. We have all these. So this is ordinal. Part F, we had exactly same example. Eye color is nominal. Value of health. Again, we had this one on top is ratio. And last one, time of day measured in military time. This is interval. Okay, now next page, here we have the process of stat. Okay, so we have these steps. The first one, identify the research objective. And so what we have here is the researcher must determine the questions he or she wants answer. The next step is collecting data. Remember on the first page here, I had that part asking questions. So where that is, okay, here on this part, we had these questions that they ask, and what the answer is, after that they're gonna collect those data. So collect the data information that we got from the first step to answer the questions posted in. Gaining access to an entire population is often difficult and expensive. So we're not going to have access to entire population. Instead, we may choose to have sample. And then step 3, describe the data. So obtaining a descriptive statistic allows the researcher to obtain an overview of data or information that they collected here in step 2. Then step 4, perform inference. Apply the appropriate techniques to extend the results obtained from the sample to population. Since here on this part we were not able to access the entire population, and instead we use sample, we're going to use all those information that we collected and extend our sample to population. So extending results obtained from sample to population and report level of reliability in the results. Okay, now working on this example. So here we have a survey of 1,026 American adults. They were asked to how of every tax dollar that goes to the federal government in Washington D.C., how many cents of each dollar would you say are wasted? So this is the question we have. Of the 1,026 individuals surveyed, 35% indicated that 51 cents or more is wasted. So they're saying that this much is wasted. And Gallup reported that 35% of all adult Americans Americans 18 years or older believe the federal government raised at least 51 cents of each dollar spent. Okay, so what I had here, that part was important. And after that, we have with a margin of error of 4% and a 95% level of confidence. We're not using this part here. This part is just to confuse us. But the questions was this part, and here they claiming that they're believing that this much is wasting. So based on that, let's answer this part. What is the research objective? Okay. Objective is to determine the number of American adults who believe the federal government raised 51 cents or more of every dollar. Okay, we want to find that. So here is to determine. The number who believe the federal government raised 51 cents or more of each dollar. Okay, so our objective was to find out how many of American adults have this belief. Part B, what is the population? What we used here? Our sample was 1,026, and that was from this group of people is American adults age 18 years or older. So this is population. This is our population. All. Instead of writing 1,026, this part is sample. And for population, we have all American adults. And these are 18 or older. What is sample? Sample is 1,026. And part D, let's see descriptive statistic. Okay, based on what the sample is, we're gonna describe this one. So of the 1,026 surveyed, 35% indicated that 51 cents or more is wasted. Okay, part E. So this is what we have here, perform inference. We want to extend this from sample from 1026, extending that to population. So extending this 1026 to all American adults. So what the conclusion is, so what can be inferred that many because we cannot find exact number for that. Here we were able to find as 35%, but we don't know how many people are here in this population. That's why I'm writing that many American believe. So many believe that the government raised. Here again, I don't know what number we have here. We have 51 cents, but here I don't know. So it's wasting much of the money collected. In taxes. Okay, so this was the first section we covered for this chapter. Later, I'm going to work on 1.2.